In this tutorial we're going to look at how you can use Datascape to visualize network graph data. The big difference between doing normal plotting and plotting a network is we actually need two data sets. We need the first data set that defines the nodes within the network and a second data set which defines the links within the network. Here we have an example of a network nodes file. The only important column is actually the ID associated with each individual record, because that is used by the links dataset to join the various points together. All the other information is purely what you need for your application. In this case we have a person's name, the city they live in, and actually a count that's been generated from the network links file. And here we have the links file. We have two important columns showing the links between the two nodes, in this case the link from node 1 to node 2 using the same numbers, the ID numbers that we had in the nodes file. And then again we can have as many different columns as we want, giving us information about these links. So in this case we've got just single category. Bringing the network data into Datascape is a two-stage process. So here we've launched the Datascape import tool and gone to import spreadsheet, and we're just going to browse so we can find the nodes file. So social graph, network nodes, and open. And we know it's got a heading row, so tick the box and then ask it to analyze. And here it shows the fields that we had in the data. We just need to set the type for each of these, so we know that's an integer and that's an integer. If we want to here, we can actually get Datascape to generate its own ID for each of the individual rows. In this particular case, because we know the IDs are unique and they're important to the system, we're going to tick the box that says we want to use this ID column. And then we're going to go to import, give it a name, test network nodes, and click on import data. So the data has been imported. Just note there's a slight bug here. It says they've all been ignored. That happens whenever you tick the import the ID column here, but rest assured they have been imported okay. That's brought in the actual node data. We now need to bring in the link data. So again we just browse to find our file. So this is our links file. Click on open, go back to analyze that. Here we've got our IDs and link type. In this case we do still need the Datascape to add an ID column just for reference, although we're not actually going to use it. And again just set these two to integer values. Go back to the import tab. Okay, and this is the important bit. We need to click network data to show this is actually link data that we're bringing in, and then choose the associated node file and click on OK. And always a good idea to click on stop on errors just in case you get a problem, and import the data set. It tells me here actually I've forgotten to change the name, so call this links, and import. And here you see it's imported all 99 of those items. So just to go across to the datasets just to make sure they've actually arrived, click on view. Here's our network nodes and associated with it here. So here we are in Datascape. First thing we need to do is to create a new workspace. Typically with network graphs you don't need to worry too much about the XY, also the X and Z coordinates, so it's quite simple just to start with a nice blank space. And we need to load unattached data and find our dataset, test network nodes, and we don't currently have a mapping created, so we're now going to create a mapping. We're going to keep the mapping nice and simple at first. Most important is the ID property here, because that must map to the IDs that we're going to use in the network links file. So ID has been mapped to ID. X and Z locations, we're just going to make those random and just give it a bit of space. So just random times 100. Likewise random times 100, just using the randomize function. We're not going to worry initially about the vertical offset. We're going to put them all as spheres, and we're going to make them all red, and we'll give everybody a size of 1, and we'll run that. And here we see the points have arrived into the space. We might want to put some hover text in, so just go to the assist. Probably quite useful to use concat so we can bring in a number of different values. So what we're going to do is we're going to have first of all their name. That's a value, or a variable rather, so it doesn't need quotes. Then we're just going to put in a hyphen, and then we'll have a city. The other thing we might do is actually offset in the vertical dimension, and within the data we've got a count of the number of links. So that could be quite useful. Just get rid of the 0 there. So basically the vertical offset is going to be dependent on the number of links a point has. We can use preview here to see actually that's going to give us a value between 2 and 19, which seems reasonable for the offset. And reload that. And drop down and look at our data. So you can just about see there you've got the vertical offset based on how many times each of those points occurs within the link file, and they're all slightly larger. And if I just hover over one of these, just make it active first of all, then I can see the names of the various people. The next thing we need to do is bring in the links file. So we select the node dataset, and you'll notice at the bottom here we've got an option of load network data. So I'm going to choose that. And in this case there's only the one links file associated with that dataset. We can, if we want to, have multiple link files associated with each of the nodes. And we're going to create new mapping. And in this case ID is just set to ID, which is said is something that the Datascape's added but we're not actually going to use. The shape for the links, we normally choose octobar. That's just really just a line that we have within Datascape, so that's the normal value to use for that. Colour, whatever you want initially. So again we'll set that to yellow. Not going to use any hover text. And now the most important part is we need to specify the ID for the A end and the B end of the line. So in this case I've got my two IDs within the data, so ID 1 and I've got ID 2. Choose that and continue. And now we can see that our network lines are being drawn in. Just go back to the data again. And if we go down to the links, you'll notice if we click on the Advanced tab, then we've actually got the ability down here to actually vary the thickness. So if we want the lines to be slightly thinner than they are at the moment, then we can just change those values there. And you'll notice we can separately set the A end and the B end. So if you've got directional links, we can, if we want to, say set 0.3 and 0.1, so we'll actually see the line in some form of point, so we get some idea of the direction of the lines as we begin to zoom in on them. Okay, so the problem we have is we've got our network in there. We've randomly assigned each point to an X and Z location, and the network ends up being a bit of a mess. And this is only using sort of 20 or so points. So what we need to do is try and lay the network out a little bit better. To do that we use what's called a force graph. So if I just go into edit mode and I select the nodes dataset, you'll see the force graph option at the bottom here. It can be a good idea just to choose one point on the network, usually probably the biggest one's probably the best bet, and just select that. The reason for doing that is that tends to anchor the network in one particular location. Sometimes you can find yourself chasing the network across the Datascape. So I'm now going to go down and choose force graph. Force graph has got two options on it, simple and advanced. The way the force graph works is for each of the points within the network, it assumes that they've got a charge, so they're trying to repel all the other points. But then for each of the links on the network, it assumes that they've got a spring, so they're trying to pull together the nodes they're connected to. And really, creating the force graph is all about just balancing out and giving it a particular balance between spring and charge, and it will then go through a series of iterations to position the network accordingly. So we're going to use the simple mode here, where all we do is set the ratio between spring and charge. I think it's probably a little bit misleading here. On the left hand side, this is actually where we have the highest charge value, so that tends to push things apart. At the other end we have the highest spring value. In that case it tends to pull things together. So for instance we're going to start off with a fairly high spring value, and we're going to run that. And you see what it actually does is it snaps the whole network together. Actually we found that can be quite useful sometimes because it sort of messes things up before you start actually trying to sort the network out. If I now actually begin to bring down the amount of springiness and increase the amount of charge, then you'll see gradually things move out, and gradually, and this particular network is quite sensitive, because as we get to the end there, all of a sudden you'll see it snaps out to a fairly large network, and we'll stop there. And it is very much a question of trial and error when you're using the force graphs. And we'll show you some of the different options as we go through this particular tutorial. So if I now zoom up and out, you'll see we've actually now got a far more useful layout. It's probably getting a bit confusing having that grid at the background, so what I'll do is I'll just change the background scenery. Just go to desert or something like that. So what you've done is you see the blue point, which is the one that we chose to fix the network around. It's actually kept that in the center because that was the most heavily connected point. You'll notice the points which are least connected, so we've got a couple here on the edges which we've got just a single two connections there, two connections there. They've been pushed out right to the edges. So what we're getting is if you like, a far more sort of natural or realistic view of how that network works. If I zoom in, then you'll see we've got the three-dimensionality of it. Obviously with a relatively small number of points here, so it doesn't make too much difference. But certainly when you start working with larger data sets, the ability to sort of pull out the most connected points above the rest of them can be very useful, not only for actually identifying the most connected points, but also for diving underneath the network so as to view the least connected points, which can sometimes get a bit buried in different sorts of visualizations. That concludes this introduction to network graphs. Please watch tutorial number 4 for some more advanced features and for some examples of more complex real-world network and social graphs.